Hey everybody, just want to welcome you to week 14, module 14 for ME111 System Dynamics. This is your final module for the semester. Thank you all so much for a great semester. A couple bookkeeping items as we go into this final module. You have your one last quiz, quiz number 14. This has been posted to Blackboard and is going to be due Friday the 4th at 4 p.m. You also have your homework number 5. This has been assigned. It'll be released on the 30th, November 30th at 6 a.m. and it'll be due a week later on Monday, December 7th by the end of the day. If you have any questions regarding your format for this, please reference your homework guidelines. They'll give you information on the format, how it's going to be graded, and how to submit it. Same as every other homework assignment exam we've done so far this semester. If you have any other questions as far as content, homeworks, grading, anything at all, how this course relates to other courses in your curriculum, I have office hours on Tuesdays and Wednesdays from 9:30 a.m. till 10:30 a.m., same as all semester. If these times do not work for you, please contact me, send me an email, a message, a chat through Teams, and we'll find a time that works for both of us. So as we get into our final module, module 14, we're going to be taking a look at some vibration applications, and I'm going to be going through some of the research projects that I've done involving vibration and relating it to some of the concepts that we'll be covering within this chapter of the textbook. So that being said, this chapter of the textbook is not included in the newest version here. So what I've done is I've posted a PDF of this entire chapter to Blackboard for you guys as a reference. So even if you don't have the older version of the textbook and you decide to get the newer e-textbook, you can still have access to all this chapter here with the PDF that I posted to Blackboard. So within this week, we're going to introduce some vibration applications, take a look at vibration control, as well as the analysis of it. So relating back to our textbook, what we're going to have is a couple goals that you should be able to achieve by the end of this module and the end of reading through this chapter 13. You should be able to analyze performance of spring mass damping elements, isolating the mass from the base excitation. 2, analyze performance of a spring and damping elements for minimizing transmission of force caused by a rotating unbalance. Now, as I relate this to some of the research work that I've done here, I'm actually going to be, in my centrifugal shaker, creating a rotating unbalance in order to create a vibration. So a lot of the stuff we discussed in the textbook is going to be about minimizing vibration. What I'm doing is I'm creating some vibrations for the projects that I'm working on. And we'll get into some more details of that as we get into my video lectures for my research projects. You'll be able to design a vibration absorber, analyze modal behavior of systems having multiple degrees of freedom, design an elementary active vibration control system, and analyze some nonlinear vibration response using numerical methods. And we'll go through some Simulink and MATLAB examples in the third section, so module 14.3. So that being said, we're going to break this module into 3 different sections. The first one being a module 14.1, and this is we're going to be looking at a research project that I've done utilizing a vibrating plate. So topics we're going to cover within this right here, we're going to look at rotating magnets, how we can utilize a rotating magnet in order to create some vibration, in our case here a vibrating plate. Looking at feedback and how feedback is important through every step along the way of this project. Motor control feedback, our whole feedback loop for determining our frequency, setting our frequency, not only for the rotating magnet frequency, but also the vibrating plate frequency. What are our disturbances in that, how we tweak the system, how we manage the motor control, and why that becomes important to maintain a steady frequency. And then take a look at frequency analysis and what we can do with the information that we obtain from either accelerometers or a couple of other different sensors as we go through this. The second section right here is going to be our module 14.2, and we're going to expand upon what we did in module 14.1 with the vibrating plate and talk about a application for a centrifugal shaker as we're looking to locate and get information from a vibrating buried object. So topics we're going to go over in this: vibration, taking a look at the centrifugal shaker design, going through accelerometers, how we use these, what information we can get from them, can we get frequency out of them, can we get displacement out of them, using other sensors in order to help calibrate our system here, in particular laser displacement sensors, looking at feedback, how we can utilize these sensors for feedback control of our system, motor control, using encoders, using information from these other sensors to tweak the motor speeds and other phases and things like that we control of our servo motors in order to get the desired frequencies we want, and then again some more frequency analysis. In our last section here, Module 14.3, we're going to look at some Simulink applications. In particular, we're going to look at a quarter car model. I'm going to go through the specifics of how to build this model within Simulink.